In this section, I will be walking you through to how to create the multiple IoT things using the Boto 3 client. Before creating the IoT things using the Boto 3 client, we need to set up the credential. We can set up the credentials in two ways. One using the AWS CLI, and another we can pass the secret key and the access key into the Boto 3 client. I'll be using the second option. While I will be creating the multiple things using the Boto 3 client, I will be passing the secret key and the access key into the client, Boto 3 client. The multiple things will be created using this program. The things will be created under this group, and we have already a policy defined for this Boto 3 client, and the things name will be created dynamically from 51 to 60. While I will be creating the multiple IoT things using the Boto 3 client, the corresponding certificate, public key and private key will also be created, and they will be saved into a particular file location. Now I'm going to execute the program to create the multiple IoT things. So you can see the things from IoT name IoT things 50 to 60 created. So total 10 IoT things is created in this execution. Now it's time to verify whether the IoT things were created or not. I'm checking the AWS console to check whether it is created or not. And you can see total 10 new IoT things is created over here. Now let's go to the things group. So the IoT things was supposed to be created under this group. You can see total 10 new IoT things has been created under this group. You can see the respective certificate, public key and the private key has been created in this location. For this section, we will be sending data from a simulated IoT device to a MQTT topic, and we will be validating the data by subscribing the topic into the MQTT client. From this program, we will be publishing the vehicle data into the vehicle/emission/data topic, and we'll be validating the data, published data from the MQTT test client. I have already subscribed the topic into the MQTT test client in AWS. Now I'm going to execute the code to publish the vehicle data into the topic. Data is sending. It's published there. You can see the data into the MQTT client. In this section, we will be publishing vehicle data into a common topic from simulated multiple devices. And same data will be received by the multiple simulated devices by subscribing the topic. Here in this code, we will be publishing the vehicle data from 3 devices into that vehicle/emission/data topic, and same data will be subscribed by the 2 IoT devices. Here in this code, I defined 3 classes for MQTT client class and one publisher class where data will be published from the devices through the topic, and one subscriber class where devices can receive the data by subscribing the topic. Now I'm going to execute the code. It's loading the data. Now I am initiating the uh, publishing of data. Now data started publishing, as well as the devices start subscribing the data. You can see here the data is published through the topic form 3 device, that is things 0, 1 and 2. Things 1 and things 2, and the same data is subscribed by the device 3 and device 4. So this explained how we can send data from multiple simulated device, and same data can be received by the multiple IoT devices.
Hello, I will demonstrate the green grass here. So, this is a green grass device, and as per the steps mentioned in the lab, I have set up one green grass core device. As you can see, it is in healthy status, and I have the device in the group, my green grass group lab 4. So if we go inside the group, we can see that the green grass v1 core is inside the group. And also, if we go inside the resource and then we see the certificates, we can see that there is a certificate created, and I have attached all the policies, required policies. So as you can see, there is IoT policy 01, Greengrass v2 thing policy, which will help creating in the thing, and then the token exchange policy to discover devices. So these policies will allow it to connect, publish, receive and subscribe. So now I will give the example of creating the greengrass, simple greengrass device, and running it end to end. I am using greengrass v2 here, as 1 is not recommended, and there are some problems with Java versions for 1. So if you see in the core device, we have the greengrass v1 core. So I will go ahead and open my Raspberry Pi. So inside the Raspberry Pi, as you can see, I have created an example, which is the Hello World example. And here, if you see, there are this recipe file and main file, which are the two main components. Right now, I have in the main file, I just have print hello from Somo Piker. So this is a most simple program, and I will just demonstrate that it is working fine. So the steps to do it is GTK component build and publish. So if I do the build, it will build it, and then if I publish it, it will publish the component in a new version. So that demonstrate creating a new version when there is a change is done. And once the version is created, we can go into the greengrass device and look into the components, and we will see this hello world program here. We can deploy a new components here, and I can use the existing deployment which I have right now. This is my existing deployment, and I will just go ahead and do the deployment. hit to review, and then I deploy it. So yeah, this will deploy the component, and you can see inside the deployments that it is active and it is deploying. So once this is deployed, we will see the log, and we can see that hello world is printed in the log. So I will just show you the output from the last run. Here is the hello world, it is printed. So I will just show the log. So this is the log, and if I open this log file, you can see that hello from Shomo Piker. This is the print statement as a standard output. Now I will demonstrate the basic discovery.py. So this is the core device created, my Greengrass V1 core, and there are some components which need to be deployed in this, like the MQTT bridge and then the IP detector. These components are deployed, and now if we see the client device, we can see that the MQTT endpoint is detected here, which is the 192.168.162, and then the associated device is thing01. And if we go in the Greengrass core, and we run this basic discovery.py, so we need to give these parameters, like I have given the endpoint here, then the root CA1, and then the certificates of the core device, like the Greengrass core, my Greengrass core pm.key, and thing name I have given thing01. So as you can see, this thing01 was attached to this device, client device. So so I have given the name thing01, and then if I run it, it will send the messages in sequence, like publish the message in hello world pubsub. So the basic discovery is working fine. We are starting with section 2. As you can see, we have used the deployment Greengrass version 2 deployment for the pubsub configuration. So let me start with the gdk.config, gdk-config.json file. So it contains our component. So Greengrass version 2 has one component and one recipe file, which I will explain you here. So the component name is this labs cs437, and it uses this S3 bucket Greengrass component artifacts. Now this is our recipe.json file. Here we are using the all the Greengrass permissions in the default config, like for the publish to topic and subscribe to topic functionalities, and then as part of the program lifecycle, we have installed the AOS IoT SDK, which will help us, this Python package will help us in doing the pubsub functionality. And then we are running the main.py file here. So as you can see in the main.file, we have included the Greengrass IPC client v2, and then we have designed the vehicles. So here first we created a dictionary which will contain we have taken like 3 vehicles for example, and the dictionary will contain for each vehicle the maximum carbon dioxide count. So now once each vehicle sends the message, it will be received here in the subscribe, and then the on-stream event will process the file. And if you can see this on-stream event, we are processing down below the on-stream event. Here once it receives the message, it will decode the message payload and then calculate the timestamp, the vehicle ID, and the maximum carbon dioxide emission. So once it receives these 3 data, it will do the calculation and found out the maximum vehicle carbon dioxide, and it will be stored in the dictionary as we mentioned above. If you can see, like, this dictionary will get updated. Max counter, list vehicle ID with the carbon dioxide emission. So when the data will be passed, it will hold the maximum value, and as and when it will receive another maximum, it will update this dictionary and send it back. So essentially this is the main.py function, and we will so this is uploaded in like in our server, in the Raspberry Pi server, and we will do the config deployment and run from there. Going forward, we will do the GDK component build and GDK component publish in our Raspberry Pi device, and once it is done, the component will be available in our Greengrass components in AWS. So as you can see, this is the component which we published, and it has the deployment. So it has the deployment version. It is deployed, and now I will show the functionality. I will explain the functionality here now. So this is the vehicle data sender, which is emulating the vehicles. So suppose this is vehicle 0, we are sending the vehicle 0 data out, and there are two subscriber I put, which is one is vehicle 0 subscriber and one is vehicle 1 subscriber, and we will prove here that when the vehicle 0 data is sent and Greengrass code calculate and send it back, it will only come to the particular vehicle 0. It will not come to any other vehicle. So as you can see, this program is sending data to a particular broadcast topic. Every vehicle will send data here. This is the vehicle data broadcast, and I will go ahead and send the data. But before that, let me turn on the subscriber for vehicle 0. So this is the vehicle 0 subscriber. I turn it on, so it is now listening to its topic, which is vehicle 0 data out, and I'm going to send the data. As you can see, when I send the data, it will calculate the maximum carbon dioxide, the Greengrass code, and it will send the data back only to vehicle 0. Now I will start the vehicle 1 listener here. So this is the vehicle 1 subscriber. So now I will change this to vehicle 1. Vehicle 1, and I will send the data now. So this will now send the vehicle 1 data. When we will send, the vehicle 1 data will only be received by the vehicle 1 subscriber and not any other subscriber like vehicle 0. So I'm going to send the data now. As you can see that the data is only received by vehicle 1, not by vehicle 0. So this proves the point that it can only send data to particular vehicle it received from. This happens because in the main program that we are running in Greengrass, here let me show you. Here we have calculated the topic based on the vehicle data which is received. So this on-stream event, if you can see, it will calculate the topic here based on the vehicle ID it receives. So this way it ensures that the data goes out only to the particular vehicle that it receives from. And also I will show the Greengrass MQTT test client. So as you can see, when vehicle data out, vehicle 0 data out, it has sent the messages and it has been receiving messages in the broadcast topic. So if it is vehicle ID is 1, so vehicle 1 data it sends back, and this was received by the subscriber end. So this completes section 2. Thank you.